What is MCB and how it works? Normally, a miniature circuit breaker is connected to the phase wire. MCB is a self-operated switch. It means when current rises above its rating, a MCB automatically trip and protect the system. Let's explore how a miniature circuit breaker detects short circuit and overloads by understanding its internal working. The internal structure of a MCB can be divided into four main sections. First section consists of bimetallic strips. Second section is the arc chamber. Third section contains electromagnetic coil and operating mechanism, and the fourth one houses the connectors. In an MCB load, current flows through bimetallic strips and electromagnetic coil. A moving part, known as a plunger, is responsible for making and breaking the connections between the input and output connectors. When current passes through this coil, a magnetic field forms around the coil. As the current passing through coil is an alternating current, the magnetic field form is also pulsating. A cylinder made up of a ferromagnetic material is placed inside this coil. The magnetic field of the coil exerts a force on the cylinder due to a phenomenon known as electromagnetism. At normal current values, a spring won't allow the cylinder to move because the force developed in the cylinder cannot overcome the spring tension. But in case of a short circuit, the value of current can rise up to 50 or even 100 times of its normal value. As a result, a much stronger magnetic field is created, which applies a significant amount of force on the cylinder. Due to this force, cylinder move and trigger the operating mechanism, causing it to immediately cut off the circuit. But it is not over yet. This sudden interruption of current can cause an electric arc to form between the contacts. The temperature of the electric arc can go as high as thousands of degrees Celsius, which can easily cause damage to our MCB. To solve this issue, we use a component called as an arc chamber. An arc chamber is designed to split this arc into smaller pieces so that the energy of arc can safely dissipate it. And that's how an MCB protects an electrical system from short circuit. Overloading condition, the current is higher than its usual amount, but not as extreme as in the short circuit condition. Because of this, MCB is not tripped by electromagnetic coil. In overloading condition, MCB uses biometallic strips to trip the circuit. When an overload current passes through strips for a few seconds, it generates excessive heat in the bimetallic strip. Due to this excessive heat, a bimetallic strip bends and triggers the operating mechanism. Circuit breaker quickly trips within 2 to 5 milliseconds during a short circuit, but in case of overloading, it takes few seconds to trip. Thanks for watching. Like, comment, share, and follow.